Okay, so there's a couple of questions here, a couple of different circuits. We'll look at the first one, and then I'm going to give you the answers for the second one, but you can work it out yourself. So what you have here is a setup that has the first one, so we're talking about this circuit here. You actually have a couple of resistors, R2 and R3, in parallel, so these guys here are in parallel, and then they're in series with this bad boy here, R1. So we should be able to find, first of all, this is what we always do, find the equivalent resistance of the combination. So what's the total resistance of that circuit? We can then find the current that flows through the combination, and then we can find the voltage across and the current through each resistor. So that's how we solve these problems. So let's find out what we have here. Well, we know that, let's look at the parallel combination. So let's look at the parallel combination of R2 and R3. I'm going to call that R2, 3, like this. So that would be, because they're in parallel, we say 1 over R2, 3 is equal to 1 over R2 plus 1 over R3. Okay, and that, if you do a bit of nice algebra, you'll see that R2, 3 is equal to R2 times R3 over R2 plus R3. I'll leave that to you as an exercise. So we have an equivalent resistance of those two resistors, R2 and R3, that can be found by that. And if you put the values in for this, if you put in, you've got 4 ohms for R2 and you've got 6 ohms for R3, the equivalent resistance comes out to be 2.4 ohms. So if you put in those values. So now we have a resistor that's this guy, R2, 3, that has a value now. We can replace those two resistors with one single resistor. So then the total resistance of the circuit is going to be R1 in series, so plus R2, 3. Now we know that R1 is 2 ohms, and now we know that R2, 3 is 2.4 ohms, so we get 4.4 ohms. We've answered the question. We now have the total resistance of the circuit. This allows us, for the next question, to figure out what's the total current flowing through the circuit. Well, we know that so we'll just call that I1. So we've got I1 here, we've got I2 here, and we've got I3 here. So remember, we've got that flowing in, and we've got these guys flowing out this way. Okay, so we can find out what I1 is flowing through the circuit. I1 is just the voltage of the battery over RT. That's 8 volts divided by 4.4 ohms. That comes out to be 1.8 amps. So we've got a total of 1.8 amps flowing through the circuit. Okay, we need to find out how that 1.8 amps is distributed between I1, I2, and I3. Well, we know I1 is 1.8 amps, and we know that I2 plus I3 is going to be 1.8 amps also. But we have to see how that's going to work. So we can, first of all, let's find out what the voltage, so we're asked to find the voltage drop across each of these resistors as well. So for R1, we know the current flowing is I1, it's 1.8 amps. So therefore, V1 is going to be the current times the resistance, so I1 R1. So that's 1.8 times 2, which is 3.6 volts. So we've got 3.6 volts dropping across resistor 1. What about the combination of R2 and R3? So we know that the voltage drop across those will be equal because they're in parallel. So we know then that V2 equals V3. So the voltage drop across those guys are equal. That's the definition of your parallel circuit. And so therefore, I2, R2, that's the drop across V2, is equal to I3, R3. Okay, so then we get, from that one, we're going to get that I3 equals R2 over R3 I2. And so that's an equation. And we also know, we know that I1 equals I2 plus I3. That's when we're looking at this node here, that's what's actually happening. We're getting I1 flowing in, I2 and I3 flowing out of it. So therefore we can say, if we just substitute I3 into this equation here, we get I1 equals I2 1 plus R2 over R3. With a bit of creative algebra. We can solve for I2 then, so therefore I2, just by rearranging that expression, is going to be I1 divided by 1 plus R2 over R3. And that's equal to, when you put the values in, you get 1.1 amps. So we know the values of the resistors. Okay, so we know the current flowing through I2 now is 1.1 amps. So it's pretty trivial to figure out how much is flowing through I3, because we've got a total of 1.8 amps flowing in, and we've got 1.1 going to I2. Therefore, I3 is just going to be I1 minus I2. And that's going to be 0.7 amps. So now we have the current flowing through all of them. And the last thing we're asked to do is find the voltage drop. And we know the voltage drop across them is equal. So we know that the voltage drop across R2 and R3 is equal. We also know that the total voltage drop, so from here to here, is 8 volts. So that's 8 volts. The voltage drop from here to here, we worked out earlier as being 3.6 volts. So the voltage drop across here has to be 8 minus 3.6. Okay, so that's going to be 4.4 volts. So V2 equals V3 is 4.4 volts. No worries. So we've got everything. We've found the voltage across and the current across each resistor. Now for this next circuit, so for this circuit here, you can see, I'm going to leave this for you to do, and I'll write the answers up. But you can figure out an equivalent resistance for this by saying 1 over, because these are all in parallel, 1 over Req is equal to 1 over R1 plus 1 over R2 plus 1 over R3. And you should get an equivalent resistance once you make sure you invert this in the end. Otherwise, you get 1 over the resistance. So the equivalent resistance will come out as being 1.09 ohms. Then you're asked to find the current through it, so that would be the answer for A. The answer for B is going to be, you're looking for the voltage as you go, so it's going to be, the current is going to be voltage divided by R, which is going to be 8 over 1.09, which is 7.3 amps. Okay, so there's going to be a total of 7.3 amps. Now, when you know that the voltage drop across each one of these is equal, okay, so there's the same voltage drop across all those, they're in parallel, then what you end up with is that I1 is equal to 4 amps, I2 equals 2 amps, and I3 equals 1.3 amps. That works out nicely. All of these guys add up to this, so the current is flowing correctly. Also, R1 is a lower resistance, so it should have more current flowing through it, and that's what actually happens. So that's the answer to that guy. So I'll let you work through that yourself.